Good day, students. I am Oluwafemi A. Stephen, your mathematics tutor. I'll be taking you through some topics in mathematics as indicated in your external examinations syllabus. The questions we are about to consider will cover 6 different topics to 8. The next question is on another topic. Do not forget that I told you that the first 10 questions will be from a single topic. Now we are in the second phase of this class where we have to consider question number 11. If you look at this question number 11, you would understand that it is not on matrices, but this particular question is from binary operations. And when you are talking about binary operation, quickly let me introduce you to it. You will understand that binary operation is just like a topic where commands are given to certain variables. Binary operation has to do with some set of rules assigned on any pair of a given set, say S, which is actually defined according to a given rule. So looking at this particular question now, you are given that A asterisk B is equal to AB plus A plus B. And another operation is given as A operation B is equal to A plus B plus 1. Looking at this, there are 2 different operations, and any of these sign could be used to denote binary operation. So you look at it, you have A operation B given, you have another A operation B given. So we are required to operate A operation B, operation A, operation C, such that it will not involve any of these given signs that represent the operation. We proceed to have our A operation B equal to AB plus A plus B. Our A operation C now will therefore be AC plus A plus C. Because according to the operation, you write the first before the second. The product of the first and second in this order, then you write the first and later add the second. So in this case, A operation C is the product of A and C. We add A and we later add C so that it will conform to the command given to this particular operation. A operation C is given, then we now want to operate A operation B, operation A operation C. We substitute. This will give us A B plus A plus B, operation A C plus A plus C. So looking at this one, we consider this one as the first, we consider this one as the second. But in this case now, it implies that the whole of AB plus A plus B has taken over the position of A, and the whole of AC plus A plus C has taken over the position of B. It implies that anywhere I see A in this marked operation, I am going to substitute this for it. And anywhere I see B, I am going to substitute this for it. So I'm now going to have the result as this is equal to AB plus A plus B plus AC plus A plus C. I will later add the constant, which is 1. So I can make a rearrangement as AB plus AC plus 2A plus B plus C plus 1. This is the correct answer. And if you look at the option, you will realize that option E in this case is the correct option as we have it on the screen. The property of binary operation that we are required to obtain here is the identity element. By the way, what exactly do we refer to as identity element? An identity element is also called a neutral element. A neutral element is called an element of no effect, just like the usual way. If you multiply 1 and 2, the result is 2. Despite that you have multiplied two numbers, the result is still one of the numbers. 1 multiplied by 2 is given to be 2, meaning that 1 is a neutral number because it has no effect on the second. Imagine a situation too where you add 0 and 5. If you add 0 and 5, you have added two different digits, but the result is still 5, meaning that that particular 0 do not change the value of 5, and hence we refer to such as a neutral element. Mark you, the neutral element under the usual addition is 0, and under the usual multiplication is 1. So we are going to use that principle to work out the identity element of this operation. The identity element of any given binary operation depends on the command we have in the operation. It can take a real value, it could be fraction, it could be 0, it could be positive, it could be negative. So we have the operation as this and want to proceed to obtain the identity element. By definition, if I operate a number and an identity element, what I will have is the number. But in this case, I am actually operating a certain variable which is n with an identity element which I have represented by e. What I will get is still going to be n because 2 times 1 is equal to 2. In this case, m asterisk e is equal to m. 2 times 1 is equal to 2 because 1 is a neutral element, is a neutral number. So I will now define the given operation with respect to this particular second equation, specifically the left hand side. So I'm going to have m asterisk e is equal to, if you look at it, it's just like a substitution has taken place. E has taken over the position of n, and I'm going to substitute e anywhere there is n. So I have this as this. So I'm going to consider these two equations. The left hand sides are equal. Definitely the right hand side must be equal. me plus n plus e is equal to n. Then I will take this me plus e to the left hand side. Then this one will go. M minus n is equal to 0. So e is common here. I will have m plus 1 is equal to 0, and e is equal to 0 over m plus 1. Since 0 is the numerator here, this expression will definitely vanish and the result will become 0. So the identity element of this particular operation is 0, and the correct option there is e. We proceed. A binary operation is defined as x asterisk 2 equal to x, and the second one, x asterisk y, is equal to x raised to power y. We are going to define the first in terms of the second. How do we do that? If x asterisk y generally is given as x raised to power y, and x asterisk 2 is given as x, it implies that x asterisk 2 can also be given as x raised to power 2. Therefore, if x asterisk 2 is equal to x squared and x asterisk 2 is given as x, we just have to equate the right hand side, which is x squared equal to x. In this case, I will have x squared minus x equal to 0. I will have x into x minus 1 equal to 0. Then x is equal to 0, or x minus 1 is equal to 0. In this case, x is equal to 0 or x is equal to 1. So the possible values of x in this question are 0 and 1, which is in option A. We proceed to the next one. Question number 14 is a question that tests for the properties of binary operations. And in this question, we have a table. And the table is prepared in mode 10. What is this mode 10? Modular arithmetic generally is an arithmetic of remainder. And if you look at it according to the given operation, that A asterisk B is equal to AB, meaning that for any numbers here, you'll find the product and express your answer in mode 10. On the table, where we have the given set is 2, 4, 6, 8. And the table is prepared in mode 10 as follows: 2, 4, 6, 8. And we have 2, 4, 6, 8. This 2 times 2 is 4. You write it because it's still less than 10. 2 times 4 is 8. You write it because it's less than 10. 2 times 6 is 12. But how many times does 10 goes in 12? 10 goes in 12 one time, and the remainder is 2. 2 times 8 is 16. And you have the result as 6. Because 10 goes in 16 one time, and the remainder is 6. We proceed to 4 times 2, which is 8. This one is 6. This one, how many times does 10 goes in the product of 4 and 6? 4 times 6 is 24. Then 10 goes 2 times, the remainder is 4. Then this times this, the remainder will be 2. This one is 2, 4, 6, 8. And this one is 6, 2, 8, 4. So we want to verify which of these properties does not hold on this given operation. Let us check for closure. What is closure? Closure has to do with a certain property such that the result obtained must still be an element of the given set. This is the product, and this is the result of the operation. As you can see, this is the result of the operation. This result of the operation has to do with 4, 8, 2, and 6. And there is no number in this result that cannot be found on the given set. So we conclude in that case that the operation is closed because we have a replica of the element of this set in the result of the operation. We proceed to check for the identity. Identity is a neutral element. Like 2 times 1 is equal to 2. 0 plus 5 is equal to 5. In this case, 1 is an identity. In this case, 0 is an identity. So let us see, for each of these numbers, 2, 4, 6, 8, if there exists any number that we operate with 2 to get 2 itself. If you operate 6 with 2, you are still going to get 2, meaning that 6 does not change it. If you operate 4 and 6, you get 4. 6 doesn't change it. If you operate 6 and 6, it doesn't change. 8 and 6, it doesn't change. So you can say that the identity element of this operation is 6, and hence it exists. We proceed to obtain the inverse. The inverse of an element A is given as A inverse. And when an element and its inverse are operating together, the expected result is E. So we now look at it that which of these numbers do we operate to get 6? If you operate 2 and 8, the result is 6, meaning that the inverse of 2 is 8. If you operate 4 and 4, you will get 6, meaning that the inverse of 4 is 4. If you operate 6 and 6, the result is still 6, meaning that the inverse of 6 is 6. If you operate 8 and 2, what you have is 6. The inverse of 8 in this case is 2. It implies that there is no element without an inverse. It also implies that the identity element exists as 6. It also implies that the operation is also closed. And as such, there is none of these properties that this particular operation does not satisfy. So the correct option there is D, all of the above. That is, every one of the given properties actually hold. We move to the next question. In this question, you have two different operations, and you are required to evaluate 3 operation 4 asterisk 5. This asterisk is an operation. This sign is also sign of binary operation. So, you are given m asterisk n equal to mn minus n minus 1, and you are given m operation n equal to mn plus n minus 2. So we want to evaluate this. We are going to start with 4 asterisk 5. 4 asterisk 5, we substitute 4 for n and 5 for n on the right hand side of this particular operation. So we have it as 4 times 5 minus n. N is 5 minus 1. So this one is going to give us 20 minus 6, which is equal to 14. I'll keep the results. Then I will substitute 14 for 4 asterisk 5 in the given problem. So it becomes 3 operation 14. This 3 operation 14 will be evaluated as 3 for m and 14 for n. 14, it becomes 3 times 14 plus 14 minus 2. So 3 times 14 is given as 14 times 3, which is 2. Then this one, you keep 1, then you add it. This one will give us 42. So you have it as equal to 42 plus, this is 14 minus 2 is 12. Adding the 2 together, you have 54. So the correct answer is 54, which is option C. The next question is question number 16. A binary operation A asterisk B is equal to A raised to power B. Then if A asterisk 2 is equal to 2 minus A, we are required to find the possible values of A. Since the question is talking about positive values of A, it implies that you are most likely to result into a quadratic equation. So this one, you have A asterisk 2 to be defined on the general operation, which is A raised to power B. Therefore, A asterisk 2 will give us A raised to power 2. We equate the right hand side of these two equations. Then we have this as 2 minus A equal to A squared. Then resolving into a quadratic equation, I'm going to have it as A squared minus plus A minus 2 is equal to 0. Factorizing this, we have it as A squared plus 2A minus 2 equal to 0. Then I will have A into A plus 2 minus 1 is common. A plus 2 is equal to 0. A minus 1 into A plus 2 is equal to 0. In this case, A is equal to 1 or A is equal to minus 2. Therefore, we look at the possible values of A to be 1 and minus 2. So 1 and minus 2 is in option A, and that is the correct option. We are asked to find the identity elements for this table. The table is given to be K, L, M, and this is K, L, N. Here you have L, M, K, you have M, K, L, and you have K, L, M, and you are required to find the identity. If you just want to get the identity is a column. It's going to fall under a certain number or alphabet, as the case may be, where you have the replica of this column. And if you trace it very well, it's on M. And if you look at it here, it is also the same thing. So when you want to find the identity element, apart from verifying from the definition, because if I operate K and M, I'm going to have K. If I have L and M, I will have L. M and M, I will still have M, meaning that M does not change the values of these other variables and even the variable of itself. So we conclude here that the identity element under this operation is N, and that is in option A. This is question number 18, still on binary operation. In this question, you are given x asterisk y equal to x squared minus y squared, everything over 2xy. And you are required to evaluate or find minus 5 asterisk 3. The method with which you solve this type of question is direct substitution. So if you look at it, I have x asterisk y equal to x squared minus y squared over 2xy. And you have to evaluate minus 5 asterisk 3. Comparing the two, you will understand that your x is minus 5, your y is 3. So substituting, we have this one as minus 5 squared minus 3 squared over 2 into minus 5 times 3. This one is 25 minus 9 over 2 into minus 15. So this one will give us 16 over minus 30. We can reduce to the least fraction. 2 goes here, 8. 2 goes here, 15. The answer will now be minus 8 over 15. And if you look at the option, you will see it in option D. The next one is on binary operation as well. You have it as x asterisk y. X asterisk y equal to x plus 2y. We are required to obtain 2 asterisk 3 asterisk 4. We are going to resolve the one within the brackets as x asterisk y equal to x plus 2y. So comparing with 3 asterisk 4, we have it as 3 plus 2 into 4. This one will give us 3 plus 8, which is equal to 11. Meaning that the result of this one within the parentheses is 11. So we proceed to obtaining the second one as 2 asterisk 11. This one is reduced to this one because we have substituted 11 for 3 asterisk 4, since that is the result according to the operation. So this one will give us 2 plus 2 into 11. So this one will give us 2 plus 22, which is equal to 24. So if you look at the question here, the correct option is A, which is 24. We have exhausted questions on binary operations, and we are now switching to a new topic entirely.